Okay, let's go through the assignment for this week, the resource partitioning exercise. This is just basic general ecology sort of stuff. I would like to show you an approach to this that I think will save you a little bit of time, and I would like to correct a couple of key points in this. One major key point that is incorrect. So if you go through this video, I think you'll save yourself some time and your life will be easier, and I think you'll get a little bit more out of it. So I'll leave it to you to read all of this assignment. Let's drop down to some of the key points here. The first thing that you're supposed to do is create this table right here, fill in the mean and the standard deviation. That's pretty easy to do. Let's go ahead and look at what that looks like in Excel. Here's the Excel datasheet minus all of this stuff that I have over here. I've added all of this right here, but here are the raw data underneath the proboscis lengths tab. So here you see the mean proboscis length, and of course what you can do is you can just highlight on each individual column like that, and then go down to the bottom and just click in equals average, and then we want, I believe it's going to be A2 through A51, and then we'll and that gives us 12.8. Okay, make sure we're going from A2. Yep. So one thing you can do to make your life a little bit easier instead of typing that in each time is just highlight this little cell right here, Control C and then Control V, and that now is giving you the mean for each of these groups. The next thing you can do is you can just type in equals and then STDEV. Let's see, standard deviation right there, standard deviation based on the entire population. We want this one of the sample, okay, and then I want, standard deviation of the sample. Yep, that's the one I want. So STDEV.S, STDEV.S, okay, and now I want A2 through A51. And that then gives me the standard deviation. And again, I can just highlight that, Control C, and then Control V. If you're using a Mac, the commands are going to be specific to a Mac. If you want to make your life easier, just go ahead and do this in the computer lab, where everybody's running a Microsoft-based machine. The other thing that you can do is you can simply highlight all of the data here like this, and then go up to the Data Analysis tab. So click on Data over here, and there's the Data Analysis tab. And then you can select the Descriptive Statistics box, which is shown right here, and click OK. And then when you do that, you get this set right here. So here we have the mean, the standard error, the median, mode, standard deviation, which is just what we computed, sample variance, kurtosis. I mean, you've not yet worked with third and fourth central moments, so you don't know what kurtosis and skewness is, but it gives a bunch of other information here that later on in your career you may rely on. So that provides this nice little table. Great. The next thing, let's look at the next little thing here in our data set. Now you're supposed to make a graph with their standard deviations of, let's see, so we're dividing, let's see, what are we supposed to do? Sketch a graph of the means with their standard deviations. Okay, so we just want means with standard deviations. They want this sort of graph. That's fine. We can do that in a slightly better way, I think. And the way I'd like to do that is like this. I'd like to use a program called PAST. And if you go to the course web page. Let's pull that up. If you go to the course web page, sign into Evolutionary Ecology, log in, and then go down to week 12. Under week 12, I've installed a button there that says Program Passed. Simply click on that, and it'll pull up the program that I'm going to use now. Let's see, there we go, right there. Okay, so here's Program Passed, and what I've done is I've already input all of those data from the Excel file. Let me go ahead and just show you how to do that. What you're going to do is just open up the Excel page, and then you'll simply highlight that group of data right there, hit Control-C, and then open up Program Passed. Put the cursor in that first cell and then hit Control-V, and it will paste all of those data. It will not have these names up here. In order to type those names in, you're going to go over here to the upper left and click on Column Attributes. And now you can go in here and you can type in the name for each column, and that's what I've done. So I'm now going to unclick that right there. And now what we want to do is we want to create this nice little graph. So what Mike Taylor is suggesting that you do is you plot the mean and the standard deviation. That's fine. You can do that. I'd like to produce something that's a little bit nicer. So I'm going to click on this very first cell here. And then I'm going to go over here to the far right and use that scroll bar and bring me all the way down to the bottom. And I'm now going to put my cursor over that lower right-hand cell. I'm going to press the Shift key, and then I'm going to left click. If you follow that sequence, you will then highlight all of those data. Okay, so now let's go up here to the menu items at the top, and we're going to press Plot. And what we want to do is we want to produce what's referred to as a box plot. A box plot is much more useful than what Mike Taylor would like you to produce, which is referred to as a dice plot. I don't like dice plots. They are full of pitfalls. Let's use a box plot instead. So here's this nice little graph, and now I'm going to come over here to plot type, and I'm going to specify box plot. Very good. So this is the plot that you can substitute. This will save you a heck of a lot of time, and it actually provides you with more information than what you would have gotten had you done your dice plot. You can now copy this plot right here. You can change the graph settings if you ever want to use one of these plots in a term paper or something. This is a very nice way to do it. Simply copy this, and then you can save it either as a JPEG or a bitmap or a scalable vector graphics file, or whatever you'd like. Okay, but let's look at what each little box here represents. So this is proboscis length over on this axis, and these are the individual species. Looking inside each box, there's this horizontal bar. That is the median. So 50% of the observations are above that median, and 50% are below. This upper line in each box is called the quartile, and there's a lower quartile and an upper quartile. And they divide the data set into fourths. So 25% of the observations are between this lower tab here and the bottom of the box, 25% between there and the median, another 25% between here and the upper quartile, and then another 25% up here. Now these ends right here are what are referred to as adjacent values, and in this case they represent the full extent of the data. So what you can see when you look at this plot is that you have two basic groups of bees. You have one group here that has relatively short proboscis, and then you have another pair up here that have relatively long proboscis. Okay? So there the question earlier was, are there major groups? Or in the instructions there's a question, are there major groups? And the answer is yeah, duh. Here they are. There's one group down there, and there's another group up here. One of the nice things about doing box plots is that it gives you a sense of whether the data are normally distributed or not. That is, do they follow a bell-shaped curve? And in order to do that, what you expect to see is that these boxes here be nice and symmetrical. So the median is roughly right between the quartiles, and these tails here are roughly even in shape. And looking at these, it looks pretty close to what you would expect from a nice bell-shaped curve. So that's a much easier way to do it than graphing it and plotting it the way you would try to do in Excel. Doing this little graph in Excel would be a very big challenge. Doing it here in Program Past is pretty straightforward. So you can do it in Excel, feel free. You can do it by hand, feel free. But this, I think, is the easier way. If you're using a Macintosh, my recommendation would be to go to a computer lab and do this on the computer lab's machines. You can go ahead and run Program Past there. It'll simply delete it as soon as you're finished. Okay, let's move on to the next part of the assignment. The results suggest two size classes of bombas based on proboscis lengths. Well, yeah, you saw that in the graph. That should be pretty easy to write down. Write a single sentence hypothesis that states how proboscis length might affect the flower size chosen by the bumblebees. Well, that's pretty clear. You can sort of sense that if you've got a longer proboscis, you can get into flowers that are deeper, right? So I'll leave it to you to figure out how to fill in the rest of that statement. Write a prediction based on your hypothesis. Well, you would expect bees with longer proboscis to use flowers that are deeper or have bigger inflorescences, something along those lines. And here I would like to make a point about some of the stuff that you've been presented in terms of hypotheses in this course. What you're getting is not completely accurate. When we talk about hypotheses, we have a research hypothesis, and associated with the research hypothesis is a couplet, that is the null hypothesis and the alternate hypothesis. The alternate hypothesis is not the same as the research hypothesis, and that's sort of a misleading thing that you've gotten from previous assignments. So as an example, let's use the idea about size in men and women. I think most people would agree that men are bigger than women, and there are all sorts of reasons for that. And we don't have to go into that right now. But let's imagine that's what we think. We have a research hypothesis that states that men are bigger than women. Fine. Now, our null hypothesis, the hypothesis of no difference, would state in a much narrower way that there is no difference in the body weights of men and women. So we're going to use weight as a proxy for bigness, okay, or size. So there is no difference in the body weights of men and women. The alternate hypothesis would be that there is a difference in the body weights of men and women. So that would be a two-sided alternate hypothesis. Now let's imagine we test that hypothesis. We determine that there is a difference in body weights. We reject the null hypothesis. We accept the alternate hypothesis. The alternate hypothesis about body weights supports the hypothesis about size, right? About men being bigger or whichever, right? And we would have to look to see if, in fact, the men were heavier than the women. If the men are heavier, then we would say, sure, we support our research hypothesis. But of course, body weight is only one measure of size. You could also use height, right? There are all sorts of other metrics that we could use. We could use volume, whatever we wanted to do. So the research and alternate, or the null and the alternate hypotheses are very specific and they're narrowly focused, but supporting the alternate hypothesis does not prove the research hypothesis. It may support it, right? But it's not the same as the research hypothesis. In this case, the alternate hypothesis was about body weight. The research hypothesis is about size. All right, so that is a pedantic point, but it is important. All right, so now let's look at this next little part of the assignment here. And what Mike Taylor is asking you to do is to make a graph of proboscis length versus corolla length. And this is in error. No, producing the graph is fine, right? But if you look at this graph, you should be able to spot the problem right off the bat. In science, we put on the x-axis, we put the independent variable, and on the y-axis, we put the dependent variable. Mean proboscis length is the dependent variable. Mean corolla length, the flower size of the flower, is going to be the independent variable. So he's got it backwards here. I don't think, right, that the length of the bee's proboscis is going to have any effect at all on the size of the flower. I think that the size of the flower is going to determine which bees can use the flower. So the axes here are flipped. Corolla length should be on the x-axis. It is independent of proboscis length. Proboscis length is dependent on the corolla. So these two axes are flipped, all right? So that's one of the pitfalls when, instead of talking about independent and dependent variables, you talk about predictor variables and response variables and things of that sort. So let's make it crystal clear so that you don't run into difficulties later on in your career. This x-axis here should be the independent variable. The y-axis depends on the independent variable. So proboscis length depends on corolla length, not the other way around. Very good. So now let's go to Excel. Here we have, and go to the tab that says proboscis and corolla length. And you can now make this nice little graph. Notice how I have corolla length here on this axis and proboscis length there. All I've done is I've highlighted these data right here, those two columns. I've gone over to the Insert tab and I've selected a scatter diagram. Okay, and I select this first type right here. And then I can specify, once we do that, let's go ahead and make another one here. So I'm going to highlight those two columns. Okay, whoops, I guess I can't do that. I first have to click this. Okay, we're going to make a scatter diagram. There we go. And I don't like that at all. I'm just going to get rid of that. And I'm going to get rid of that right there. And this is backwards, right? Because this has, on this axis, it has proboscis length, and on this axis, it has corolla length, and that's incorrect. So we need to change that. So we're going to do a couple of things. First thing, let's right-click on it and select data. And I'm going to remove all of that, and I'm going to add something. So now I'm going to select the X value. So I click in this little box right here. And for X, I want corolla length. So I'm now going to highlight corolla length and hit enter. And for the Y, I want proboscis length, so I'm going to highlight proboscis length, like so. Very good, and I'm going to click OK. All right, and click OK. That's all good. Let me get rid of this graph up here if I can. It's not going to go away easily, so let me just get it out of the way. There we go. Okay, so now let's just look at this graph. This doesn't have any labels or anything of that sort on it, so let's fix that. Let's highlight this graph, and let's select this option over here and click on that. And now I can get rid of my chart title, get rid of Series 1, like that. And now I can click on Axis Title right there and just delete those things and put in my own title. And this is going to be Corolla Length. And did I spell that correctly? I did not. Length. There we go. Do the same thing over here and get rid of all of that, and then type in proboscis length. There we go. Okay, so now this is a graph that you could then right click on it and, well, how can I save that? There is a way, copy, well, no. There is a way to copy this. What you could do is you can move it onto another page and then copy it that way. Or you can use the snippet tool to copy it. If you don't know about the snippet tool, just click on the little window icon down below and type in snip, S-N-I-P, and it'll come up with this icon right there. Wait for it to pop up. There we go. And it's right there. So I'm now, I hope you can see that. Maybe not. Okay, if you can see it, I'm clicking on new. What I can do now is I can just, showing up on the right window. There we go. Yeah. So you can just do that using the snippet tool, and you can now save that as a bitmap or whatever you would like. Okay, JPEG, whatever. So there you can see by looking at this graph that there are these two very nice clusters, right? So there seem to be two groups of corolla length flowers, flowers with relatively small corollas and flowers with larger corollas. Very good. Okay, so we're not going to save that. Good. Let's go back to the instructions now and see what else we need to take care of. So you need to look at that and decide whether it meets with your predictions and so on. And now what he's asking you to do is to produce this, this graph here. You're going to break the data into these size classes and so on, and then analyze the data in some form like this, which is seems to me rather tedious. I certainly wouldn't want to do it that way. And I don't expect you to do it that way either. So let's simplify that a little bit, shall we? Let's go into Excel and let's look at the flower visits a little bit like this. And here you can see I've already done all of this. Here's what the data look like. All we have to do is divide the data up into these classes. And the classes are based on length of the corollas. Okay. And what I've done is I've divided them up into 4 groups that look like this. So a corolla length from 0 to 3.9, from 4 to 7.9, from 8 to 11.9, and from 12 to infinity, I guess. And then all I do is I put my species names right here. And I put my size classes for the corollas up here. So the 0 to 3.9, 4 to 7.9, and so on. And then each of these is simply, if you highlight on that first one, is just the sum of how many visits by this first species. Let's do this one here just because it'll stay in the same window. So this is sum of C3 to C8. Notice how I've highlighted the different groups, and that's just to make my life a little bit easier. So I want to know how many flowers, how many visits were there to flowers in the size class. All I have to do, right, is type in here equals sum. So let's do that. Equals sum, and then open paren. And then I just have to highlight that group right there and hit enter, and it finishes it for me. And I've done that for each group here so that I now have this nice little table. Okay, and now rather than producing these stacked graphs the way you've seen in the assignment, you can do it like this. So go to Insert, and now we want a column chart like this, and we want a two-dimensional column chart, so that's this one over here on this side. You simply hit that and select the data, which is what we have right here, and it will produce this nice graph. So now you have species along this x-axis right here, size classes along the z-axis, and then number of visits on the y-axis. And when you look at it, the difference is pretty clear, right? You have these two species right here, which are visiting the large flowers. And then you have these three species over here, which are visiting the smaller flowers. So simply produce that graph, and then you can use the snippet tool. I don't know if it will, yeah, there is a way to save these directly, but you can use the snippet tool to make your life a little bit easier. So I think if you follow those steps, this whole assignment will be just so much quicker. You'll have less agony and aggravation over that, and you'll be done in a hurry, and you can be finished with this assignment. Good. If you have problems or questions, don't hesitate to email me. And in the meantime, have a glorious weekend. Talk to you guys later. Bye.